Let's have a look at question 9 then. I have to say I think this is probably the hardest question out of all the multiple choice questions I gave you in this mock, but we'll see how we go about it, and hopefully when you realise how to get into the problem it's not actually that bad. As with all things, the trick is to be able to see how to get into it, access the actual problem. Okay, so a car accelerates uniformly from rest along a level road. The effects of air resistance on the car are negligible. The car travels 12 metres in the second of its journey. How far does it travel in the 4th second? Right, the first thing I would do, and I'm going to do in order to explain this to you, is I'm going to draw out a velocity time graph. So here we go. There's my time along the bottom. I'm going to have velocity up there, and there's my origin. And it's saying that the car accelerates uniformly along a level road, so and it's starting from rest. So we're going to go from rest, and we're going to accelerate uniformly. And it's telling me that in my second, I wanted that to be a 1. That's going to be my second, that's going to be my third, and that's going to be my 4th second. So 1, 2, 3 and 4. And what it's telling me in the question is that the car travels 12 metres in the second of its journey. So what that means here is that this area between 1 and 2 seconds represents a displacement of 12 metres. What that also tells me is, because it's doing it in 1 second, is that the average velocity between 1 second and 2 seconds has to be 12 metres per second. So the average velocity would be there, and that's going to be at 12 metres per second. And I know that it would be travelling at 12 metres per second at a time of 1.5 seconds. Now, because I've got a point on the graph, and in fact I've got 2 points on the graph, I can work out the gradient of the line, and of course the gradient of a velocity time graph is the acceleration. Excuse me. So let's have a look. So I know that the acceleration is the rate of change of velocity, so delta v divided by delta t, and I'm starting from rest, and in 1.5 seconds I have increased my velocity by 12 metres per second. So if I put those numbers into here, we can get my acceleration is going to equal the change in velocity, 12, divided by the change in time, which is 1.5, and then that gives me an acceleration of 8 metres per second squared. Okay, now the question is actually asking how far does it travel in the 4th second. So in the 4th second we're looking for this area here, and again what I'm going to do is I'm going to work out, well, this area here will be its average velocity between 3 seconds and 4 seconds, and that will happen at 3.5 seconds. So if I can work out what that velocity is, then that will tell me how far it's moved in that second. Now what I could do, which is the long way around, is, because I know my acceleration, I could use some Suvat equations starting with u equals 0, and I could work out how fast would it be going at 3 seconds, how fast would it be going at 4 seconds, and therefore work out the displacement as it changes its velocity in that 1 second. Or because it's a uniform acceleration, I can realise, well, if it was travelling at 12 metres per second after 1.5 seconds, then because the acceleration is 8, it would be travelling at 20 metres per second after 2.5 seconds, and therefore it would be travelling at 28 metres per second after 3.5 seconds, and after 3.5 seconds that will be the average velocity between 3 and 4 seconds. So my answer is A, 28 meters.